Today we will be talking about how to derive a third order gears method, the integration formula. And because this is part of my assignment, and when I was researching online, I didn't see anyone talking about it, so I just figured why not make one tutorial video myself. I think this will be helpful for, I don't know, for anyone who is interested or who is faced with this kind of requirement, or I don't know. So let's just start, okay? So in order to derive an integration formula, we need to know the structure of the formula, right? So integration formulas can be derived by an interpolating polynomial function, which can be expressed as this. So because we are deriving a third order, we need the n should be equal to 3, right? So let's just write it down. So I use VT, but you can use whatever you want because I'm dealing with a transmission line here. So this is my choice of the symbol, but like I said, you can use whatever you feel comfortable with. And we also need the derivative of the polynomial function, which is like this. Right? And as you can see, we have 4 unknown variables, A0, A1, A2, and A3. So the purpose of the whole thing is to get the value of A0, A1, A2, and A3 and substitute them in this function, right? And in order to get this, we need 4 equations because there are 4 unknown variables. So here you can see in this graph, what I did is this is the function, this is the VT function that we want to know, right? And because it's third order, we have choose the previous 3 time points, and this is the fourth time points, and T0, T1, T2, T3. And let's assume the time step is h, okay? So T0 equals to h, T2 equals to h, T3 equals 3h, okay? So to get the 4 equations, you can basically choose whatever you want, right? You can substitute T1 in here, and then T2, T3, and then you can substitute T0 in here, right? But my choice is this. V0 equals to, V0 is VT0, right? V0 equals A0, V1 equals to A0 plus, this is here T equals to H, right? Because it's T1. And V2 is 2H. So here and yes, this is what we get. And the fourth one, we will be using the derivative. Okay, V3, okay, dt, and so basically you swap out t with 3h, right? So it's a1 plus 6 a2h plus 27 a2h square. And now what you should do is you should calculate a0, a1, a2, a3 based on the 4 equations. And I will be using, let's write it in matrix form because I will be using the MATLAB to calculate, because this, if you calculate manually, it will be too difficult. Here, and h should be 0, 0, 1. Right, and here should be A0, A1, A2, A3. So this matrix is what you're interested in MATLAB when you write the equations, right? Here's V0, V1, V2, and dV3 dt. Okay, and this is how you write the code in MATLAB to let MATLAB calculate A0, A1, A2, A3. So first you have to define all of this thing as a symbol, right? Other than, because if not, the MATLAB will assume it's like a variable or something. So you don't really need T. H, V, O, V1, V2, and dV3 is basically the symbol for dV3 dt, and this is the matrix that we got, that I wrote down in my notes, and C is the VO, V1, V2, dV3 is like the result you get from the equation, like the right side of the equation. And because we want to know A0, A1, A2, A3, they basically are this B matrix. Because if you write it down like that, it would be A times B equals 3, right? And A is this matrix, B is the one we are interested in, and C is the results. So then you calculate, right? You hit run, and then in this window, they will give you the, okay, it's here. They will give you, the MATLAB will give you the results that you're interested in, because it's a 4 by 1 matrix. So here is the first, here is for A1, and this is for A2, this is for A3, and this is for A4. Okay. And after putting it in MATLAB, the MATLAB system will give you the following results. I'm just going to write it down here. I will plug in the video of me running MATLAB so that you can understand. Okay, this is what MATLAB gives me. Okay. Okay, and let's write down once again the equations. Okay, so what we need to do is we just only need to swap out A0, A1, A2, A3 with the thing that we got from MATLAB. But what I'm going to do here is I'm going to use V3, okay? So V3 equals to A0, not A0, V0 plus T here should be 3H. So for V3, yes, 3H, right? So it should be, I'm also gonna put the negative sign back into the bracket so it looks better. Okay. Right. Here is C11, 6, dV3 dt. Okay, this is the first, this A1t, right? And here we swap out A2, which is okay. And this is for dV dt. And let's swap out A3. So A3 is this. So it's dv dt. Okay, and then we only need to calculate, right? So it's 1 minus 22, 117, 90 plus, it's not plus, should be negative. Here's okay, I'm just trying to speed things up. And here is, so forgive my handwriting. 117. V2 and dv3 dt. So this is what we'll be having. Okay, and then we only need to swap out 3 with x. And for v0, then it's x minus 3, right? X minus 3 plus, not plus, minus 2. Okay, and there you have it. This is the differential equation for the third order method, Gears method integration formula, right? Oh, here's this mistake. Here should not be dv3, so it should be dvx dt. And that's it. And I'll be including the second, fourth, and fifth order just in case you're interested in, and you can derive them similarly using this method. So the second order should be, I'm just gonna copy it from the material that I got. So here it uses y. Okay. And instead of h, you use a delta t, which is basically the same thing, right? And fourth order, minus 3, and this means the derivative. This means like the derivative, right? The fifth, I also include the fifth one, but it's kind of getting long. I don't think that anybody will be asking you to derive the fifth order. But you can always use MATLAB. Okay. And just in case you wonder, let me write it in the same form as the fourth and fifth one. This plus 1 equals 2. Okay, if you're gonna like do it, I think I'm gonna the same order. Minus 1. Okay, and this is what you will get. And I hope this has been helpful for you. So thanks for listening.